Hey guys, Pre-Calc 231. Today we're doing 1.6. So last class you did the increasing and decreasing intervals. So I think that puts us at a date of Friday, October 2nd, which should be where you are. So what you guys are doing today is 1.6, which is operations and compositions. You can check the pile. I may have made copies of this. It's not something that you desperately need copies of. But obviously, if you have it there, then use it. Otherwise, this is right on Schoology, and you can use it for the classwork and the homework for once the video is done. It'll be that section and that section, which is what you want to do. But certainly, these notes are good too. I do go through similar ones, or maybe even the exact same ones in the notes. Some of them might be the same, some of them might be different. But certainly, you can use it for a reference. Otherwise, do this warm-up the best you can and pause the video. If you're really lost on how to do it, then just keep the video going. All right, so this first one, I want to do f of 2, right? So what I would do is I would look at the f equation, which is this one. Right? It's not an equation, actually, it's just a graph. So if it's f of 2, well, it's not f of x, it's f of 2. So what I want to do is I want to find the equation's value where x is 2. Right? Instead of f of x, it's f is 2. So I would have to look here and say, okay, well, the x value is 2 right there. So what's the equation's value at 2? Well, it'd be -1, right? So f of 2 is -1. Right? F of 4 is, okay, well, it's not f of x again, it's f of 4. So if this is the equation, this is 4. What's the equation value? Well, it's 4 comma 5. Right? So the equation value is 5. Now in this one I want g of f of 3 is what it's saying. So what I do first is always do the innermost one first. So f of 3 is right here, right? If I plug in 3 for f of x, it spits out 3 as well. So what it's really looking for, since f of 3 is 3, it's really just looking for g of 3. And now I don't want to work with this one, I want to work with this one because this one's g. And all it's saying is plug in 3 for x, right? It's not g of x, it's g of 3. So you want to plug in 3. So that would give you 5 over 3 times 3, which is 9, plus 1. Right? So I just plugged in 3 for the x, which is 5 over 10, which is the same thing as 1/2. And then finally, g of f of 4, right? So I look at f of x again and say, okay, f of 4, well, if I plug in 4, it's going to get 5. So it's going to really be asking me for g of 5, since f of 4 is the same thing as 5. So if I did g of 5, I would say 3 times 5 is 15, plus 1 is 16. So that's the denominator. The numerator is still 5, so I get 5 over 16. Right, so there's your warm-up, a little bit of a preview of what we're going to be doing in a minute. So part 1, this is broken up into 2 parts, right? So part 1 is operations of functions. And in these operations, what we're just going to be doing is this one is the same as the classwork that's on Schoology, or maybe you have it in front of you if I did make copies, right? We're going to be doing the sum of 2 functions, the difference of 2 functions, the product of 2 functions, and the quotient of 2 functions. So in other words, we're going to be adding, subtracting, multiplying, and dividing. Those are all 4 operations that we can do with functions. So we're going to say f of x is equal to x plus 1, and g of x is x squared minus 1. So if I wanted to do this first one, which is f plus g of x, right, and we're going to write it like this, f plus g of x. All I want to do is take the entire f of x equation, right, f of x plus g of x. So I'm going to do x plus 1, which is f of x, plus g of x, which is x squared minus 1. And then you're just going to add like terms together and get an answer. So when you get, you add your like terms, you can write it in descending order, so the biggest degree first. So it's going to be x squared, and that takes care of this one, plus x, And then finally we have 1 plus negative 1, which is 0. So your answer is literally just x squared plus x, right? It's pretty basic stuff. Now notice how if I did g plus f of x, would you get the same equation? Yeah, because you'd still be adding the two together. It wouldn't make any difference. Subtracting, though, would make a difference, right? If you think about subtracting it, make a little room, right? If we're going to do f minus g of x, right, looking like that, so I'll draw it out. So if I'm going to do f, hold on, screwed up something. Okay, so if I'm going to do f minus g of x, right? Now I'm taking f of x, which is x plus 1, and I'm subtracting, always good to use parentheses here, g of x, so x squared minus 1. Now when I do that, I can do that, make this a plus, and then make everything inside the opposite. Certainly you can do it that way. So if you did it this way, you would end up with negative x squared first term from this one, plus x here, and then 1 plus 1 would actually be plus 2. Now notice how if you did g minus f of x the other way around, you would have written this one first and then minus this one, you get a different answer. So this one's unlike addition in that order does matter. This next one with multiplication, so product, order doesn't matter. You're basically just going to FOIL here. F times g of x is how we're going to write it. So we have f times g of x, right? And that's basically just saying we're going to multiply the two together. So you would have x plus 1 times x squared minus 1. And you can FOIL it out. For the sake of time, I'm not going to FOIL it, but you would get x to the third. And then plus x squared. And then I think you'd have minus x and minus 1. And that would be your final answer when you FOIL it all out and put it in order. That's what you get. The last one is division, which kind of might seem like the easiest one, and sometimes it is, but sometimes you got to go kind of an extra step. So you would just write it as f divided by g of x. F divided by g of x. And you're literally just putting the entire f of x equation on top and the g of x equation on bottom. But you're going to see what happens here, right? So f of x was x plus 1. That's x plus 1 divided by x squared minus 1. But whenever you have the division, you always want to look to see if you can take it further, and you can, because x squared minus 1, right, x squared minus 1, right, the numerator is still x plus 1. But x squared minus 1, you can break up into x plus 1 and x minus 1, right? They're conjugates, and they'll give you that. And then when you do it that way, x plus 1 in the numerator is going to cancel with this x plus 1 in the denominator, and you're left with 1 over x minus 1. So you always want to look for that with the division. Make sure you can't reduce it. And if you can, keep going. If you can't, then you would just leave it the way it was. But this one we could. Okay? So those are all of your operations on functions, right? I can give you any two functions, and you can add them, subtract them, anything like that, especially with ones like these where they're lines or quadratics. And that's it. So that's it for part 1, and then we're going to start part 2. So part 2 is compositions. It's kind of like what we did in the warm-up, right? It's doing f of g of x or g of f of x, or j of b of x and b of L of x, whatever. It's just two functions, and you're basically plugging in one into the other. So if I said f of g of x, you're taking the entire g of x equation in which case this is the entire g of x equation, 2x minus 3, and you're plugging it in to the x within the f of x equation. So it's f of g of x. The innermost one is the one that you plug in. So it's really the same thing as f of 2x minus 3, which just means instead of saying x plus 1, you're going to have 2x minus 3 plus 1. And then you would simplify even further and you get that. Right? And if you did it the other way, right, you're plugging in g, or for g of f of x, you're plugging in the entire f of x equation, x plus 1, into the x within g of x. Right? So it's g of f of x, you're plugging in f of x for g. So that's the same thing as instead of 2x minus 3, it's going to be 2 times x plus 1 instead of x minus 3. And then you would simplify and get that. Okay? What you always want to keep in mind if I ever ask you for the domain of a composition of functions, the innermost domain must always be part of the final answer. And I'll go through why in a second. So we'll take a look at this example. If I said f of x is the square root of x, and g of x is x squared, and I said find g of f of x, right? You basically would want to say, okay, well, I'm going to plug in f of x into, so I'm plugging in this into the x right there. Right, so instead of saying g of f of x, I can just say, I'm going to plug in the square root for the x, so it's going to be square root of x, and then squared. And then you say, okay, well, the square root of x squared is just x, so that must be my final answer, right? And it is, but if I ask you for the domain, right, you might look at x and just say, well, the domain is anything. I can plug in whatever I want. However, the innermost function, which was f of x, you have to consider that domain, right? The innermost function was this. Your domain for the square root of x is 0 to infinity. Now, the domain of just x is anything. However, you have to consider what it originally was. So it was the square root of x squared. So if you just looked at the innermost, the square root of x, you can only plug in 0 or positive numbers. Even though the final answer was anything negative, you could have never plugged in negatives to begin with. So that's why we say the domain of the innermost function must always be part of the final. It doesn't have to be the whole thing. You know, if we had to put it in a denominator, you might have another stipulation in there. But you must always consider it, right? It doesn't ever go away. So the f of x, the domain was 0 to infinity. Your final answer is x, right? But you also have to say the domain is just 0 to infinity because the innermost function's domain was 0 to infinity. And that's it. So your classwork and homework sections, that's all you're going to do for the rest of class. So you should have a good chunk of time. Again, it looks like this. So we already did this first part. So you can go ahead and do page 89, 5 through 24. And then the second part, again, we just did these. Also, I didn't mention it, but instead of saying f of g of x, we could also do f and then like a little circle, f of g of x this way too. It means the same exact thing. It literally means f of g of x, or g of f if you wanted to switch them. It basically looks like it's multiplied, but it's an open circle instead of closed. So if you see that fog, that just means f of g of x. Same thing as this one. But then just kind of looking at the notes again. The notes do a good job of explaining how the domains work. So if you want to look at that second example, that's a really good example. These are good steps. I just kind of highlighted them there and just mentioned them briefly in the slides. So certainly look through those. And once you're done with that, you can start doing this stuff, which this is probably what you'll end up doing for homework. My guess is you'll probably finish these in class. They're quick. But then do this one for homework, or whatever you don't finish, do for homework. And that's it.